Good morning, everyone. Now that we've survived the nukes, let's say this happens to you. You've been coding nonstop on something you want to share with your friends, and it works on your MacBook. You want it to stay up when your MacBook goes to sleep, or you get on a plane or a train or into a car on a bus or something, and all you have to do is the easy task of just putting it into production. It's easy, right? We're in the future. So just add a Docker file, they say. So you do that, and then you have a Docker image that you can push to your target machine, and then you find out the real horror of Docker. You can't just push the image to the target machine. You have to push it to a registry. So you make an account of the Docker Hub, you run into the rate limits, and then you have to move to something like GitHub Container Registry, cache all your upstream images, and then you finally pull it on a VM running on someone else's computer, and then you need to figure out the other really fun part. You need to configure Nginx. As is standard in our industry, it uses its own bespoke configuration language that no other program on the planet uses. Once you get past that, and all of the Googling, and all of the syntax checking, and all of the failed syntax errors, ask me how I know, you end up with the real final boss of the internet, DNS. It's never DNS until it's always DNS. So you install the artist formerly known as Terraform, Lego, provision your DNS and HTTPS certificates because, of course, in Anno Dominium 2023, Nginx doesn't do this for you. And then you're done. You hacked up your service in, I don't know, an hour. And then you look at the clock when you've done all this, and it's been 17 hours. This is madness. Why do we have to put up with this? Why do we have to put up with cloud infrastructure that's so deep in the Kool-Aid that you end up with an entire event sourcing pipeline just to run a freaking Tamagotchi? You're just trying to make an HTTP service show up on the internet. You don't need to know what an ALB, EKS, ECS, IAM, or PFA is. But, of course, complain about this on the internet at your peril. A certain Tangerine community funded by Big YAML will decry that you should use Kubernetes to simplify all of this into easy to understand and discrete units with a bunch of YAML. They conveniently omit that the most common way to deploy things is use a string templating language for structured data where space matters. There has got to be something simpler here, right? So whatever happened to just pushing a binary to a host and running it there? Why do we have to deal with this stuff? Why do we have to deal with security groups and IAM and DNS or HTTPS or any of the slings and arrows of outrageous venture capital investment? What if you could just describe the state of the system you want instead of going 3 layers deep into a level of DevOps hell that you will never return from the same? I think that this is the real value of something like NixOS. Today, I'm going to show you how to turn an arbitrary Go program into a NixOS service and then expose it to the world thanks to Tailscale Funnel. This means that you can link it to your group chat of friends and restore the balance to the force or whatever it is you Zoomers do in your group chats. All that said, let me just introduce myself for a second. I'm Iaso. I write that one blog that you keep finding when you Google Nix and NixOS stuff. I'm a writer, gamer, philosopher of chaos magic, and you've probably seen my blog on popular news aggregators. Today I'm going to cover a few core things that you can make your own NixOS modules. I'm going to cover what a NixOS module is, why you should care, the parts of a module, and then how to make your own, and then we're going to really tempt the demo gods, but that's an extra surprise for later. But before we get started, since we're all limber from the nuclear blast warnings, raise your hand if this is your first exposure to Nix and or NixOS. Huh, a few of you, okay. Raise your hand if you've used it before. Yeah, about what I expected. So what if you have it installed on a server at home? Raise your hand. Basically the same people, yep. So how about you lucky few that are allowed to use it in production? Raise your hand. Oh, that's actually way more than I thought. Okay, you're very lucky. You can all lower your hands now. So for those of you that are new with this, Nix is a package manager that lets you declare all of the inputs for a package and hopefully get the same output. It's basically turning the process of building a package into effectively a function. So you have all of your you have your package build inputs, any dependency inputs, and then you return either a package or the universe blows up and everybody dies. At the time, I'm using a Go function syntax here to represent what's going on, but Nix conveniently uses its own DSL for this, also named Nix because there wasn't any good option at the time. Remember, Nix was the result of the lamentations of the state of the software industry, and I guess Eelco really liked Haskell. But to help you understand the relation between these things, I've put up this helpful diagram with Rainbow Comic Sans, because that's how you know it's a legitimate diagram. And Nix is NixOS, but Nix is not the DSL that's used to define NixOS stuff. And Nix packages is the standard library of Nix stuff, but it's not the same as NixOS, and it's not the same as the DSL because, you know, standard libraries are totally different than the core language, am I right? The way I like to think about NixOS is this. NixOS is the consequence of trying to use Nix to build Linux systems. You can think about NixOS as a bunch of pre-baked snippets that you can combine into one discrete unit to do whatever you want. And each of those snippets is called a module. Here's an example of a very simple module from my home lab. In Nix syntax, this is a function. A NixOS module is a function that takes the current state of the world, like the existing configuration options, the packages that are available for the system, and then it returns any changes to make to the state of the world. So in this case, the change that it's making is enabling the Prometheus node exporter. This is part of my home lab cluster named allrest, and I have it set so that whenever you declare something as part of that cluster, it just automatically puts Prometheus in there and does some rigging to make everything just magically work. There's no way to enable it or disable this, there's no knobs, but this is fine because for the most part, I don't need it. If you really want to have knobs though, you have options. Options are effectively little configuration knobs that let you do things like enable or disable settings, or like customize which package of something is used. So if you need to rebuild like drone to up the build limit or something, you can do that way. In this case, this is the configuration for managing my minimal plugin-free vimrc on all of my systems. It is a home manager module. It's kind of like a NixOS module, but just think about it as like Nix for dot files. And what this does is whenever you enable it with within.vim.enable equals true, it'll just plop the vimrc in the right place and make sure Vim shows up in the path. Options are what let you take an existing module and do all of the spacebar heating you want. So if you wanted to use this, you need to like import it somewhere. Let's say for the sake of arguments in ./vim, you'd import it and then twiddle with the knobs until you get what you want. It's easy. So the state of the world is the input and the new changes are outputs. This is what lets you build things up to get whatever you need. Oh, and by the way, that Nginx syntax thing wasn't just a bit. NixOS actually lets you configure Nginx syntax directly from inside NixOS, so you don't have to context swap between the like 40 different DSLs that you have to use to manage a modern Linux system. I love it. Of course, things become a lot more fun when you start declaring your own NixOS modules for your own applications. I have an example program here. It's something that just shows a bunch of quotes from the legendary British science fiction author Douglas Adams. So when it's running, it'll look like, oh, did we just lose HDMI? Oh, we're green now, okay. We were purple before, but we're green now. So you basically load it, it shows a bunch of words, and in this case, these words are funny because it's Douglas Adams. What else would you expect from the author of the 5-part trilogy, The Hitchhiker's Guide to the Galaxy? So overall, the infrastructure for this is going to look like something like this. I have a VM running on my MacBook. It's a brand new NixOS VM, and I am going to be configuring it with a flake for the application, and I'm going to add it to the flake for the system, and we're going to hook everything up, and it's just going to work. I hope. The real fun comes when I expose this to the internet from conference Wi-Fi on my laptop live. So let's hope the demo gods don't hate me today. And all of the other stuff involved with like exposing to the internet, Let's Encrypt HTTPS is going to be handled by Tailscale because it's really convenient. And I don't want to have to do Terraform in the conference. So that's my cue to hop over to VS Code. Let's see. Oh, there we go. Perfect. So I have a VS Code session with the flake configuration for this Douglas Adams quote server. Oh, it's... yes, it would help if I put it on the right monitor. I am so sorry. Extended display, mirror. Okay, did that do it? Margins are a little weird, but we'll roll with it. So I have a flake here. This flake is basically a set of inputs and a set of outputs. It's basically just another weird way to write a function. In this case, the input is Nix packages, which is the standard library of Nix that includes all of the package definitions for things like Go or Rust or Yarn or anything that you could have in the Nix land, including Python. So these inputs are, you can have an arbitrary number of inputs and then also a bunch of outputs. The outputs are what you can do with it. For example, the outputs I have defined here are a package for the program. I have a NixOS module for the program. I have a development shell, which is a development environment. And I have a check that runs on AMD 64 Linux, but I can't run that here because I have an AArch 64 MacBook. So let's start out with the dev shell, which I think is like one of the most foundational parts of Nix that is really what sold me on it. So let's imagine a world where your computer doesn't have any developer tools installed by default. You don't have a C compiler on your command line. You don't have anything. It's just an empty shell with like the basics to keep the system running. A development environment lets you statically declare what everything needs. So in this case, we have a Go program that needs some other Go tools, the Go language server, the Nix formatter to make VS Code shut up, and the Node.js runtime, and also Yarn because there's a node dependency for the CSS. Again, modern computer stuff. So by default, if I press Control-Shift backtick, yeah, I think that's the thing. Is this big enough? So I'm going to run nix develop to get to a development environment, and then I'm going to do yarn start CSS. And what this is going to do is going to rebuild the CSS on the fly with a tool called Tailwind, which you can think of as like a whole bunch of utility classes for CSS, so you don't have to like suffer. So I didn't have Yarn installed anywhere except for inside that development shell. So it just works, it's magic. I love it. Where's the button? There's the button. So now that we have all of this, let's look at what the package for this thing would look like. A package is effectively like the same as an apt or DNF or RPM package. Except you define it by saying what Nix needs to do to build it. In this case, it's going to build a Go module with Go 1.21. It's going to make a package called Douglas Adams quotes. I have an automatically generated version here, just trust me. I have the source at the current directory, and I have a vendor SHA-256 equals null because this only depends on the standard library. If you have external dependencies, you're going to need to figure out what the hash is for all of them, and it'll work out. This package is called default because it's the default package for the program. That's just a conventional name. So if we do nix build, we get the package, and wow, that was fast. Result bin Douglas Adams quotes, and we'll see that it claims to be listening on port 8080. So Now comes all of the rigging to make it a NixOS module. So one of the things that NixOS exposes as a bunch of knobs is the ability to create systemd services. And you take a package, you run it in a systemd service, and then, you know, bam, somehow you've got like an internet working. So in this case, I made a NixOS module, or I made a set of NixOS options under z.services.douglasadams quotes. And I have enable, I have something to change the log level, I have the port, but the most important part is this little configuration of, this little snippet of systemd configuration down here. All of these things correlate with the systemd unit file parts. For example, there's a description, there's a wanted by to say what it's depended on. You can do after and before and all of the standard systemd stuff. But if you need an escape hatch, you can also do direct service config, which more directly maps to raw systemd configuration. So in this case, we're going to use dynamic user equals yes because it's the future and I don't want to have to create a user account for every darn service I write. And it's going to run the program in the package, or allowing you to customize the package in case you want to change the CSS or something. That you specify the log level and the port number that it's going to listen on. Every one of these options correlates the CLI flags in the program, so you can do things like have an enumeration for what values are allowed here, so you can only have debug, info, or error. And for the port, there's a special type for ports so that you can assert that it's a number between 0 and 65535. It's pretty great. The only thing that you can't do with this is secrets, because Nix doesn't currently have a native representation of secrets, but there's ways you can work around it with AGNix exercise for the reader. So we have everything we need now. We have a package, we have a module, and we have a development environment. This is the foundation of what you need to get something working with Nix. So let's tempt God by actually deploying this to the production server. Let me show you what that would look like. I'm just going to get into there real quick. So this is connecting to my VM over Tailscale, all that fun stuff. And Flakes also have the ability to output NixOS configurations. So not only can you output modules, but you can output entire system configurations and you can share them around like that. It's really cool. So in this case, I have a VM named Douglas Adams. It is running AArch64 Linux, and it reads from configuration.nix, which is a bunch of automatically generated things, a custom host name, and some other bookkeeping stuff that's really super boring. 5? Okay. So you would, in order to use it, you would import the Douglas Adams quote service into your thing. You would add the module to your system. In this case, I have an inline module to enable it, and let's yeet this into prod. So let me just SSH into it real quick. Okay, NixOS rebuild switch -- flake etc NixOS. Okay, are you gonna do it? Hey, it started it. Cool. So we have this Douglas Adams quotes.service. And it's running. And it's listening on port 8080, just like before. And if we do a curl command, we get, wisdom. So now let's make this available to the internet. Get your phones out, because I'm going to be actually exposing this to the internet on your conference Wi-Fi, and I'll have a QR code for you to scan. So I'm going to serve this over HTTPS. I'm going to enable funnel, it's like ngrok to put it to the internet, and let's go from here. So scan the QR code, and you will be able to connect to my laptop, to a VM on my laptop on conference Wi-Fi, and be able to see immortal wisdom. You can trust me, it's not a Rickroll, right? Yeah. Oh, I'm so glad that worked. Oh, where is the thing. Did it not refresh when I hit the next slide button? Oh, the slides aren't updating. Okay, cool. We'll just leave that up there and, okay. So NixOS modules aren't hard. It's just weird. It's just a bunch of options to configure things to get what you want. You can have custom options to add your own knobs. You can use other people's options to twiddle them how you want and heat your space bars. And your programs can just become services. It's easy, I promise. Now you hopefully know how to make your own NixOS modules for fun and profit. Oh, this works, okay. So before we get this talk wrapped up, I just want to thank everybody on this list for helping make this talk shine somehow. This really helped. It was a lot to work on. And with that, I've been Z. Thank you so much for coming to this talk. I hope you've had a good conference. I'll be wandering around in case you have any additional questions. I'll post a summary of the code samples on my blog so you can look at it some more. I'll post that this evening. Oh, and if you're looking, Tailscale's hiring. I'll try to answer every question I can, but if I can't get to you, email dynamicuser@zserve.us. Thanks again to the organizer for having me, and I hope you have a good day. Yeah, sure.
2 minutes for questions.
Hi. First off, great talk.
Thank you.
Even though the circumstances. Second off, regarding secrets, how are you plan to implement it, or?
I'm not part of the Nix team. However, I know that this is enough of a pain point that people are working on it. There's a workaround called AgeNix, which will encrypt the secrets against SSH host keys, because those can only be read by root in, the Platonic ideal of Linux system security. So that's usually what they do to shim around it. It's kind of a hard problem in general because it's a completely declarative thing where everything is world readable in /nix/store, and that includes your secrets, which depending on your threat model may be a bad idea. However, if you're not too worried about your threat model or you don't have your configurations open to the public, it's probably fine to just put them in there and hope things don't go bad. It really depends on your threat model though, and I don't know what your threat model is.
And to add to that slightly, there's nothing that prevents you from doing stuff at runtime, like you have KMS or Vault in the cloud or whatever, and you can fetch stuff from there, and that also works. You just don't put it in your NixOS configuration, you put a specification of where to fetch the secrets at runtime in your NixOS configuration, and that works.
Yeah.
It's not NixOS concern.
It's not a NixOS concern explicitly. However, it's enough of a pain point that it probably should be for basic convenience reasons. Okay. Thank you.